Let's look at matrices for GCSE further maths. Example 1, here's matrix A, and they want us to work out the matrix 3A. To do this, we just times the matrix by 3 on the outside, and we just times each individual element by 3. So that will be 12 minus 3, 0, and 21. Example 2, this time we have two matrices and they want us to multiply them together. In this order, AB would be this matrix multiplied by this matrix. Now, something important to note here about the dimensions of the matrices. By that I mean how many rows and columns there are. This matrix is called a 2 by 2 matrix because it has 2 rows and 2 columns. This matrix is called a 2 by 1 matrix because it has 2 rows and 1 column. Now, in order to be able to multiply matrices together, these dimensions have to match. In other words, the number of columns in A need to equal the number of rows in B. In this case, they do, so we can multiply. Now, when we multiply them together, we can use the dimensions to tell us how big the answer is going to be. And in this case, it's going to be a 2 by 1. And the reason for that is that we can use the outer dimensions to tell us this. Our next job is to actually do the multiplication. This can be a little bit confusing when you first do it. To fill in the top number, we need to multiply first row by the first column. Specifically, we do 2 times 3 plus 1 times 4, and that gives us 10. So that was from doing 2 times 3 plus 1 times 4. For the second number, we need to multiply the second row by the first column. And to do that, we do 0 times 3 plus 1 times 4, which is 4. Again, I'll just write a note here, 0 times 3 plus 1 times 4. Example 3, another two matrices that we want to multiply together. So in this case, CD is going to be this. I always check the dimensions. So this is a 2 by 2 and a 2 by 2. Inner dimensions match, which is good. The outer dimensions tell us how big the answer is going to be. So in this case, looks like we're actually going to get a 2 by 2 for the answer. Now let's do the multiplication. So for the first row, first column, we multiply the first row by the first column. In this case, that will be 4 times minus 7 plus minus 2 times 2, which gives us minus 32. Now you can do this in whatever order you like, but I usually then go to the first row, second column. So now we're going to do 4 times 0 plus minus 2 times 6, gives us minus 12. Next, down here, second row, first column, let's do minus 1 times minus 7 plus 5 times 2, 17. Last one, second row, second column, minus 1 times 0 plus 5 times 6, which is 30, and we're done. Example 4, and this example involves the concept of the identity matrix. The identity matrix is a special matrix, usually denoted with capital I, and it looks like this. As an example, 1, 0, 0, 1. The reason that's an example is that's the 2 by 2 identity matrix, but these can get as big as you need them to be. So a 3 by 3 would look like this, and a 4 by 4 would be like that, but bigger, and so on. The reason the identity matrix is special, and what gives it its name, is that when you multiply any matrix by the identity matrix, the matrix stays the same. So let's say you had matrix A multiplied by I, the answer would be A. And it doesn't matter which order you do that multiplication in, I times A in that order would also be A. Whilst we're here, I want to talk to you about another special matrix called the zero matrix, usually denoted with big O or 0, and that's just a matrix full of zeros. Again, that's a 2 by 2, but you could have a 3 by 3, 4 by 4, and so on. What's so special about a zero matrix is that any matrix times the zero matrix is just 0. So we could also have 0 times A, also 0. You need to know about both the identity matrix and the zero matrix for this course. Now that we know that, let's go ahead and do the question. So example 4 has two matrices multiplied together equal to the identity matrix, and we need to work out the values of A, B, and C. So first thing I would do is actually multiply these two matrices together. Again, checking the dimensions makes sense. 2 by 2 times a 2 by 2 gives us a 2 by 2. And then when we multiply these two together, using the method that I showed you in the previous examples, we would get something like this. Don't let the algebra put you off, it's just the same thing we were doing before. In this question, apparently that answer is equal to the identity matrix, and in this case that will be the 2 by 2 identity matrix, so here. And our job is to work out the values of A, B, and C. From here, this is just a matching exercise really, so you can see that the zeros here and here already match, which is great. And then from here, C must be equal to 1. 2A must be 1, therefore A is a half. And then finally, 2B minus C is 0. Since we know that C is 1, that means 2B minus 1 is 0, therefore B is also a half. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.